On January the 21st, 2019, a rare lunar event called a super blood moon is set to take place. But what really is a blood moon, and how do they happen? The lunar eclipse, or blood moon, is a phenomenon that has held significance to many civilizations living centuries before the present day. The Incas, for example, were well known for deifying celestial objects, including both the sun and the moon. This meant that any event that deviated from their day-to-day experience of nature and astronomy was considered a sign of terrible things to come, and when they saw the deep red hue that the moon took during a lunar eclipse, they were afraid. They believed that a jaguar had attacked and eaten the moon, and in order to protect the Earth from a similar fate, they shook spears at the moon and made noise in order to scare away the large cat and prevent the destruction of the Incan civilization. This isn't the only time that humans have feared the appearance of a blood moon. According to Christianity, the blood moon is a symbol representing the anger of God, and in some cases, the crucifixion of Jesus. Yet when the theory and science are applied to these events, they become phenomena that are not feared, but celebrated, and so the significance of the lunar eclipse has changed throughout the ages. So why do lunar eclipses occur? Contrary to a solar eclipse, where the moon blocks out the light from the sun to the Earth, a lunar eclipse occurs when the moon passes through the Earth's shadow. The reason that we don't have a lunar eclipse every full moon is because of the fact that it doesn't always align perfectly every time it orbits the Earth. Syzygy is the word that astronomers use to describe the alignments of celestial bodies, and this is the event that will be occurring on the 21st. So if the moon is passing through the Earth's shadow, why does it appear to be red when surely it should be dark? The answer to this is given by refraction, the bending of light when it passes from one medium to another, such as light from the sun travelling through space and then through the Earth's atmosphere. If the light travelled only in a straight line, we will get a cone of shadow, or umbra, behind the Earth. But since some of the light can bend around the Earth, it is able to refract just enough to hit the moon. This solves the puzzle of why the moon isn't completely dark during a lunar eclipse, but does not explain the red colour of a blood moon. To answer this, we need to ask another fundamental question about our world. Why is the sky blue? It's not a question that seems immediately obvious to ask in order to solve the problem, but rewind back to 1859, where an Irish physicist by the name of John Tyndall was investigating the ability of a gas to absorb radiant heat in the Earth's atmosphere. Tyndall required the gases used to be free of suspended particles of matter, and one way to test for the presence of dust and particulates was to shine white light on the sample. If the gas was impure, the dust would scatter the instant light due to an effect now known as Tyndall scattering, giving the sample a slight blue tinge. In 1871, British physicist Lord Rayleigh later backed up the claim that this blue colour was due to dust, with a mathematical explanation of the effect. It wasn't until 1899, however, that Rayleigh showed that the scattering was not only due to dust, but was also happening at the molecular level, with individual gas molecules being responsible for the scattering of light and the blue colour of the sky. This subsequently became known as Rayleigh scattering. This still doesn't answer the question though. If light is being scattered, why should a blue colour appear? To decipher this, it helps to think of light being made up of waves, with different colours of light being associated with different wavelengths of light. For instance, blue light has a shorter wavelength than green light, which has a shorter wavelength than red light. It also happens that white light is not made up of one colour, but is in fact an entire spectrum of colours. This can be shown by refraction through glass, and is the same effect that gives rainbows their distinctive colours. The wave theory of light was well established during Rayleigh's time, so they were able to formulate mathematical expressions to predict the amount of scattering with respect to the wavelength of the incident light. What did he find? That the scattering due to the molecules in air has an inverse relationship with the wavelength of the light. That is, the smaller the wavelength, the higher the amount of scattering. Knowing this, we can now explain what is happening when we perceive the blue colour of the sky. White light from the sun travels through space to meet the Earth's atmosphere, where the shorter wavelengths of light, making up the white light, are scattered by the atmosphere. These colours are mainly blue and green, while the longer wavelength colours, such as red, are scattered less and so pass through. The shorter wavelength colours are reflected until they meet with your eye, so that you perceive the sky to be blue. Likewise, if the sun is viewed with appropriate filters, It's not purely white, but has a yellow tinge to it. This is due to the absence of the blue and green light waves, which gives a higher proportion of yellow and red in the remaining light. Now imagine yourself standing on the moon. As the light from the sun travels towards you, it has to pass through the Earth's atmosphere in order to reach you. The blue wavelengths of light are reduced in intensity by the atmosphere due to Rayleigh scattering, and as the light has to travel further through the atmosphere than it would have to if you were viewing it on Earth at midday, even more of the blue light is absorbed by the atmosphere. This leaves a reduced spectrum of wavelengths of light that can pass through the atmosphere to reach the moon, a high proportion of those colours being a red hue, hence the red colour of a blood moon. It would seem like the sun is rising or setting below the Earth from your perspective, and it isn't too dissimilar from a sunset on Earth. The same logic can be used to explain why the sun turns red. The eclipse that will occur on the 21st is a special one, and has been given the name Super Blood Wolf Moon. In fact, the next time you will be able to see an eclipse of this type isn't until 2036, so it is truly a spectacle that you won't want to miss.